Welcome! Today we're going to dive into the incredible story of what is, for sure, our species' single greatest invention and our most powerful tool.
So just think about it for a second. What is it that truly sets us apart? What's the one thing that allowed us to build entire civilizations, create breathtaking art, and even travel to the stars?
You got it. It's language. This one single ability is really the foundation for almost everything we think of as human.
It's incredible, right? Language lets us take a thought from our mind and plant it directly into someone else's, whether they're across the room or across 1,000 years. But that just opens up some huge questions, doesn't it? Like, where did this thing even come from? Can other animals learn it? How is it literally wired into our brains? And maybe the biggest one of all, does the language we speak actually shape the way we think? So yeah, these are the massive questions we're going to explore right now. Okay, so our first stop, it's a huge evolutionary mystery. How did language even begin? I mean, there's no fossil record of the first words ever spoken, right? So we have to be detectives, piecing the whole story together from clues in our biology and our history. So our journey to language, wow, it was an incredibly long one. We're talking millions of years. The very first hints, the brain's wiring for speech, like Broca's area, that started showing up 2 million years ago. Then you get the simple proto-language, maybe starting with Homo erectus. But get this, the actual hardware for modern speech, our vocal tract, that only showed up around 60,000 years ago. And here's the crazy part. It came with a huge trade-off. We got the ability to speak, but it also meant we had a much higher risk of choking. Wild, right? And then, maybe 40,000 years ago, a key genetic tweak might have been that final piece of the puzzle that just sparked this boom, this explosion of culture and art. So, what exactly was that proto-language our ancestors were using? Well, think of it like language version 1.0. It had words, sure, vocal labels for things like lion or water or hunt, but it was missing the grammatical rules, the syntax, that lets us combine those words in all these creative ways. It was a really, really crucial first step. And that leads us perfectly to our next big question. If language evolved in us, could we teach it to our closest relatives? Can animals actually learn language? Now, to answer that, we first have to agree on what true language even is, because it's way more than just communication. It's got to have a few key features, like displacement. That's the power to talk about yesterday or tomorrow. But the real secret sauce, the magic ingredient, is something called recursion. This is the ability to nest ideas inside of other ideas on and on forever. It's the difference between saying the man ran and the man who saw the cat that chased the mouse ran. See? That's the engine of all linguistic creativity. So, the first big attempt to teach an animal language was with a chimpanzee named Washoe. Now, since chimps can't make human speech sounds, they taught her American Sign Language. And the results, they were amazing. She learned about 150 signs, and then, most famously, she saw a swan on a lake and signed waterbird, a totally new combination she made up herself. It really seemed like a massive breakthrough. But then came Nim Chimpsky. This was a project designed to be way more rigorous, and, well, it found a pretty different story. Nim learned 125 signs, yeah, but the researchers noticed that 90% of the time, he was just signing in response to his trainers, and 40% of his signs were just him parroting what they had just signed to him. His longer sentences, they were mostly just repetition, like banana me, banana eat, not the kind of structured grammar a human child just naturally develops. Okay, but the most convincing case by far is Kanzi, a bonobo. What's amazing about Kanzi is that he was never formally trained. He just picked up a symbolic language by watching researchers try to teach his mom. He learned spontaneously, just like a little kid. He could even understand the difference between put the ball on the hat and put the hat on the ball, which shows he actually had a grasp of word order, a really key part of syntax. So, what's the final verdict? Well, when you put them side by side, the differences are pretty stark. Apes communicate almost entirely about the here and now, and usually to ask for something, like food. Kids, on the other hand, talk about the past and the future all the time, and they ask questions, constantly, just to learn and to share information. So while apes are obviously incredibly intelligent, they just don't seem to have that spontaneous, creative, and structured grammar that really defines human language. So, if our language ability is so unique, where does it come from? To figure that out, we need to look inside our own heads and explore the brain's actual blueprint for language. For more than 100 years, we've known about two key language centers in the brain, mostly in the left hemisphere. A good way to think about it is this.
Broca's area is like the director. It sits in the frontal lobe and it organizes the structure of your speech, all the grammar. Wernicke's area, on the other hand, is the scriptwriter. It's in the temporal lobe and it manages the meaning of words. It's like your own personal mental dictionary.
But here's the thing. It seems like our brain doesn't keep this amazing language learning machine switched on forever. There's this idea called the critical period hypothesis, and it basically says there's a special window in childhood when the brain is super plastic and just perfectly primed to soak up language. It's kind of a biological use it or lose it situation. And that raises a really deep and pretty difficult question. What happens if a child doesn't get any language input at all during that critical time? What happens if they miss that window? Tragically, history actually gave us an answer. In 1970, a 13-year-old girl named Jeannie was discovered. She had been kept in extreme isolation her entire life, cut off from almost all human contact, and, most importantly, from language. Her case became this painful but scientifically vital test of that critical window hypothesis.
So, what did the researchers find? It was fascinating and heartbreaking. Jeannie could learn words. I mean, hundreds of them. Her vocabulary was actually pretty big. But the grammar, the syntax that glues all those words together into meaningful sentences, she never got it. She couldn't build complex sentences, she couldn't really ask questions properly, and she couldn't use those little grammatical bits and pieces like adding an S for plurals or ed for the past tense. It's like she could learn all the individual Lego bricks, but that critical window to learn the instruction manual, the blueprint for how to build with them, it had already closed.
This brings us to our final and, honestly, maybe the most mind-bending question of all. We know we use language to express our thoughts, but could it be the other way around? Could our language actually be shaping our thoughts? This is the core idea behind something called the Sapir-Whorf hypothesis. It suggests that language isn't just a mirror that reflects our reality. No, it's more like a lens that actually shapes and filters how we perceive everything. The very words and grammar we use might just be building the world we'd experience. Just take color, for instance. Different languages carve up the rainbow in totally different ways. Where we in English have separate words for blue and green, the Shona language just uses one for both. And the Dani language goes even further. They use just two terms for the entire rainbow, one for dark, cool colors, and one for light, warm ones. So you have to wonder, does that mean they actually see the world differently? And the evidence for this stuff is pretty powerful. Think about the Paraha tribe in the Amazon. Their language literally has words for one and for two, but any number bigger than that is just many. And researchers found that without having words for numbers like 7 or 8, the people in the tribe just couldn't reliably do tasks that required counting that high. Their language seems to actually constrain their ability to think numerically. So from our deep evolutionary past to the wiring of our brains and to the very fabric of our reality, language is so much more powerful than we usually imagine. And that leaves us with one last big thought to chew on. If the words we use really do help build the world we perceive, what kind of world are we building for ourselves every single day with the words we choose?